Hello everyone, welcome to this video. I will show you in this video what is GP and how we can calculate sum of infinite GP terms. So firstly, I thankful to those nice persons who watching my video and likes my videos. So let's start with GP. So firstly, I introduce a general term of GP just like an AP. So firstly, in GP is just very similar to AP, so the difference is only small thing, that is product. The product means multiply. So firstly, the general term of AP can be written as firstly it is written as A, then AR and AR square and ARQ and so on. Okay. Now this is the general form of GP, that is geometrical progression. One thing you should note that just like an AP, our we introduce first term same as A. First term is here our A, means A is our first term, that is this one. Okay, so the just like an AP, in AP we introduce common difference, but in this case, that is in GP, we introduce common difference. Not common difference, it's common ratio. Okay, so I introduce in GP is common ratio. Okay, common ratio, and it is just nothing but R. So basically when you divide like that, you divide this thing, you get R. A and AR cancel out and R is left. Similarly, if you divide this term to this, only R is left. So it means common ratio is constant, and that is our R. And if I am talking about how we can calculate the nth term, so we should see the pattern. So what is the pattern? Again, I rewrite our general form of GP. So now notice it and see the things very carefully. Okay. uh, so our main purpose is to find the nth term, means nth means is last term. We generally suppose n is our last digit, so according to n, what is our last term, or we can say general term of nth term, or we can say Tn. So okay, one thing you should note, that let me change color. Okay, a is present everywhere. A is here, A is here, A is here, so it means A is obviously present at the last term, so I write here A. Okay, now come at the point R. I notice that in my, this one is my term 1, T1, suppose T1, and this one is T2, and this one is T3, and this one is T4. T is nothing but terms. Okay, so if I notice this is 2, means T2, and R the raised power is 1, means 1 is less. Similarly T1, and I can write as R to raised to power 0, and here is T3, so here is T2, here is T4, here is R to raised power 3. So it means if here is n, then it means a power is 1 less, so it means power is 1 less is nothing but n minus 1. So this is our my general nth term. Okay, so let me rewrite it clearly. So okay, so uh, Tn is A R to raise to power n minus 1. That's it, the general nth term. If I'm talking about the sum, how can we calculate a sum of GP? But as you know, to calculate sum, we have to memorize the formula. But if you are not interested in calculating the you are not interested in memorize the formula, I give you one trick. That trick is, firstly you have to add all the GP terms. For example, Sn is basically a sum of all the GP. First term was our A and next term was AR. So I just write plus sign between every term because the main point is to we have to calculate the sum. So that's why I write like this. AR square and up to so on nth term because here is n. So as we calculating above, our nth should be like this AR the power n minus 1. So this is the sum, but this one is not the formula. Our main purpose is to drive the formula, not memorize the formula. So what I did, I just multiply r with this term. So whenever I multiply r with above equation, it become like that. Suppose I multiply this with r, and here is rsn, and I deliberately give a space here. Okay, let me explain later why I take space here. So firstly, I just take a space here, and whenever r is multiplied with a, it become ar. Okay, so here is ar come from this side, and if I multiply r with ar, it gives us ar square. So I write ar square here. Similarly, so on, it gives us ar n minus 1 because the term before here is r2 raised to power n minus 2, and when it is multiplied with r, it gives us ar raised to power n minus 1. But the thing is, whenever r is multiplied with this term, it gives us a r raised to power n. Now the thing is, here is one space is added and one space is come here one more because I deliberately giving a space here. So now if I suppose I subtract this equation, let me change color again, it is choose black. So I take a negative sign everywhere because my main purpose is to subtract. So if I subtract, we clearly see Sn is here, Sn is here, it means Sn is common. So Sn is I take a common, and what is the left behind? It is 1 minus r, and ar is cancelled out with this ar. Similarly, ar square is cancelled out with above ar square, and so on up to ar n minus 1. So what is the left behind? Minus a. Okay, this a is also left, so I write here a minus a r raised to power it's n, right? So again I common this a. If I common a, what is the left behind? 1 minus r2 raised to power n. So basically, so what I left, Sn, I take this term to the this denominator. What is the left behind? A 1 minus r2 raised to power n, and divided by 1 minus r. So this is the formula if I want to calculate the sum of finite GP. I'm not talking about infinite, I'm talking about finite. So this is a formula for finite for every r can be anything, you know but it is not zero, because if r is zero, so what is the left behind? Only a. That is the not any sense. So uh, that's obvious thing, it's for every r but not for zero. And so this is a formula for every hour. Now, some books, what can they do? They just take one negative sign outside and adjust below. So this formula can be also rewritten as a r2 raised to power n minus 1 and r minus 1, because minus sign can be adjustable in if I'm taking common from numerator, it can adjust in denominator. So this is the formula. Okay, now let me show you one more thing for infinite GP. Before I write here what is the formula for finite GP. It is nothing but a 1 minus r to raise to power n and divided by 1 minus r. So this is for a finite GP. But the thing is, if I am talking about infinite GP, to calculate infinite GP, if in question they have mentioned one particular thing, what was that particular thing? Let me write. Suppose they write GP is going to infinite, and that their common ratio should be lie between -1 and 1. Obviously, I subtract 0 because 0 no sense, and r is belonging to -1 and 1. So if I want to calculate this for infinite, what I have to take, because our n is going to infinite, I take a limit and approx to infinite, taking Sn. So what was my formula from here? It is a 1 minus r to raise to power n and divided by 1 minus r. I taking a limit and approx to infinite. Now, as in given condition, we know r is lie between -1 and 1. So basically, it is in fraction. For example, if r is my 1 by 2, if I taking a power 2, it become 1 by 4. It is going to more close to 0 whenever I raise to n going to infinity. So basically, our r this r to raise to power n is nothing but going to 0. If it is going to 0, what is the left behind? It is a divided by 1 minus r. So this is the sum of infinite term of GP if I want to calculate. So this is a formula. So that's it. Thank you. Have a nice day.